Okay, good afternoon everyone. Can you hear me? Can you hear my voice?
Sir. Sir.
All right, so we'll start now. I had asked you before the starting of this lecture to just go through one of the videos that I uploaded on YouTube. Was there any problem with that? Did you go through it? Yes, did you go through it? All right, so we'll start now. What we are going to do in today's session is we're going to look at certain examples, certain problems that have come in university exams, not necessarily our university, but even from Pune University or Mumbai University, and we are just going to look at those problems and how we are going to solve them. So today we are going to look at three important problems that we are going to solve together. All right. So we'll take this session until 3 today because at 3 you will have to attend the lecture series. So we'll try to finish the session before that. All right. So I hope you have your pens, pencils, calculators, and your paper ready with you. We are going to solve this problem. As always, I'll be giving you a minute or two at every point in which you're going to calculate the values, calculate the answers, and at that point, you're going to write the answers in the chat box. So everyone keep your chat box open because we will be requiring the chat box. We will be communicating through the chat box. So just going back to what we finished in the previous lecture or of the previous revision video that I uploaded on YouTube was about classical method of optimization. So classical method of optimization depends upon two things. First is the necessary condition. The necessary condition is basically the condition in which you equate the first derivative of the function to 0 and find the values for variables. So at these points, the extrema lies. Now, what is the nature of this extrema can be found out by using the second, that is sufficient condition. That is, you take the second derivative of the function and put the values of x that you have found out in the second derivative. If they are less than 0, then it is a maxima. If it is greater than 0, then it is a minima. If it is 0, then you go for third derivative. If the third derivative is 0, you go for the fourth derivative and so on until you get a non-zero derivative. Now if the derivative is if the derivative at which the value is non-zero, if it is a even, then you use the same condition again. If it is negative, it is maxima. If it is positive, it is minima. If it is odd, then it is neither maxima nor minima, but a inflection point or saddle point. So that is what we studied in the previous video. Now we are going to use that and we are going to solve this problem. So this is the first problem that we are going to solve. So write down this problem. I'll give you about a minute. So write down this problem. Assume the following relationship for revenue and cost function. Assume the following relationships for revenue and cost function. Find out at what level of output X, where X is measured in tons per week, profit is maximum. So this is the question. Write it down properly. R of X, which is the revenue, R of X, which is the revenue, uh, is given as 1000x minus 2x square, 1000x minus 2x square, and c of x, which is the cost function, is given as x square minus 59x square, x cube minus 59x square plus 1315x plus 5000. So these are the things that are given to you in the question. Most of the companies do this thing where then whatever their output is, they measure their profits, they measure their revenue, they measure their cost as a term of this or as a function of this particular output. So here it is said that the profit depends upon revenue and cost. So you know that the profit is always revenue minus cost. So that is the thing that we're going to use. So now when we start with the solution, what is the first thing? The profit function, as you know, is a subtraction between revenue and the cost functions. I've written it twice here. Is a subtraction between revenue and cost functions. All right. So based on that, I'm going to find out profit of x is equal to revenue of x minus cost of x. So with this, what I want you to do is find out the function for profit of x. Can you find the function for profit of x? Please find the function for profit of x. Revenue of x is given to you and cost of x is also given to you. So based on that, you are going to find the function for profit of x. Profit in terms of x. So the profit function is 1000x minus 2x square, which is revenue function, minus x cube plus 59x square minus 1315x minus 5000. So that becomes your profit function. If you subtract the like variables, so x and x, if you can subtract, square and square you can subtract, so the profit function becomes minus x cube plus 57x square minus 315x minus 5000. Has everyone got this? Has everyone got this? Please use your chat box so that we can continue. All right. So now profit of x, you have got this function. Now you want to maximize the profit. All right. You want to find out the maximum profit. At what point will the profit be maximum? At what value of x will be the profit will be maximum? That is what you have to find. So basically you have to maximize this function with respect to x. So that is what we are going to do. And for that we are again using our classical method. So what we are doing is start with the necessary condition. The necessary condition states that we first take the first derivative of the function and equate it to 0 to find the values for x. That is exactly what I am doing. I am finding the first derivative of the function. So p dash of x is minus 3x square plus 114x minus 315. So you know that the derivative of minus x cube is minus 2x square plus 57 into 2, that is 114 x minus 315. So that becomes your first derivative. Now we have to equate it to 0. All right. So now for maxima and minima, I'm going to equate this derivative to 0. So I'm going to equate it to 0. So the function becomes minus x square plus 114x minus 315 is equal to 0. Now with this, can you find the values of x? Please find the values of x and tell me the values of x. Giving you a minute. Please find the values of x. Please find the values of x. Yeah, a couple of students have found out. Yes, I need more answers. Pratik Joshi, Navnit Kumar have found it out. Got an answer from Jay Amte. A few more answers. Come on, everyone, you can solve this. Okay, so when you solve this, the values that you get are for x are 3 and 15. Sorry about it. Yeah, the values are 3 and 15. So these are sorry, 3 and 35, not 15. I'm sorry about that. 3 and 35. So the values for x are 3 and 35. So these are the points at which your maxima or minima could lie. So that is the thing. Now we want to find out whether it is maxima at these points or whether it is minima. We want to find out what is the nature of these points and what is the nature at this particular point. So for that, we have to use the sufficient condition. What is sufficient condition? We find the second derivative of the function and then put these values of x in it and check whether they are positive or negative. So that is exactly what we are going to do. Okay, so I'm going to differentiate the first differential to get the second differential. This becomes d2p upon dx square is equal to minus 6x plus 114. So that is the second differentiation that I have done. So that comes out to be minus 6x plus 14. Now what I'm going to do is put these values of x in this, put the values of x in this particular point. Okay, so whatever x I have found out, 3 and 35, I'm going to put that value of x in this equation and check whether it is positive or negative. So let's start with 3. At x is equal to 3, what will be the value of this second differential? Can you find out? So basically I'm putting 3 in the second differential equation to find out the value. Yes, I'm getting a few answers. Come on everyone, please solve it. So if I put x here as 3, okay, the value that I get is 96. So minus 6 into 3 plus 114 is equal to 96. So now what does that mean? 96 is positive, it is greater than 0. So therefore P is minimum at x is equal to 3. Alright, so P is minimum at x is equal to 3. So that means in the factory, if we just manufacture about 3 tons per week, we are going to have the minimum profit. Alright, but we do not want that, we want maximum profits. So here what we are going to do is we are going to go to the next condition. We are going to put x is equal to 35 in the second differential. All right, so I'm going to put x at x is equal to 35. Can you find out the value? At x is equal to 35, can you find out the value? Yes, it is minus 96. So minus 6 into 35 plus 114, that gives you minus 96. So what does minus 96 mean? It is less than 0. The second differential d2p upon dx square is less than 0 and therefore p is maximum at 35. So this is the answer. The maximum profit is at x is equal to 35 tons per week. So if your production is at 35 tons per week, you are going to have maximum profit. Okay, so this is the answer that you have to write. These are the word problems. So for word problems, at the end of the word problem, you are supposed to write uh, the exact answer in this line, in a particular line or in word format. So you are going to write, hence the profit is maximum at x is equal to 35. Always remember the units after that. So x is equal to 35 tons per week. If they ask you what is the maximum profit, okay, here it is not asked in the question, but I'm asking you now. If we ask what is the maximum profit, can you find it out? Can you find out the maximum profit? Maximum profit. How do you find out maximum profit? So we have found out we get maximum maximum profit when x is equal to 35. So we put x is equal to 35 in the original function of x. Okay, and whatever is the value that we get is the maximum profit. Can you find out the maximum profit? What is the maximum profit? Yes, come on, I'm waiting. What is the maximum profit? Not getting answers, so I just got one answer till now. Yes, a few answers. Come on, everyone. I want you to solve it. Run your calculators. Without that, you're not going to get a practice of it in the exam. The maximum profit is 10,925, whatever units, whether it is rupees or dollar, whatever is given in the question, always pay attention to that. And that is your maximum profit. All right, clear? I think it should be clear. This problem was pretty simple. Now, uh, we can go to the next problem. We'll go to the next problem. Write down this question. This is the next question. I'll give you a minute to think over it. Think about it. What is this problem and what are we going to do? How are we going to solve it? Okay, the question is a beam of length L is supported at one end. If W is uniformly distributed load per unit length, the bending moment M at a distance x from the end is given by M is equal to 1 half Lx minus 1 half Wx square. Okay, so we have to show that. Okay, so there's some mistake in the problem. A beam of length L is supported at one end. If W is uniformly distributed, then show that. Okay, so there's a small typo here. We'll just add that. Then show that the bending moment M at a distance x from the one end is given by M is equal to 1 half Lx minus 1 half Wx square. So this is the question. So how are we going to do this? All right. So as always, we are going to start with the necessary condition and sufficient condition. How is this a optimization problem? That is the question. Okay, so the bending moment will be maximum at any particular point. Okay, so that is why we are trying to find out the maximum bending moment in terms of the equation. To solve this, what we are doing is, given that bending moment is given to us as 1 half Lx minus 1 half Wx square. So this is the bending moment given to us. We are going to take, we're going to differentiate this with respect to x for necessary condition. So what are we going to do? So we are going to differentiate with respect to x. So I'm going to find dm by dx, and that will be equal to 1 half L minus Wx. Alright, so that is the necessary condition. I'm differentiating with respect to x. Now this equation I'm going to equate it with 0 and find the value for x. So what is the value for x? Can you find it out? Can you find out the value for x? What is the value for x? Yes, it is L by 2W. So that is the max value for x. So it is for minima and maxima. For extrema, we are equating the first differential with respect to x and finding the value of x. So x will be equal to L by 2W. So that is given to you. That is what we have found. Then we start with the sufficient condition. What is sufficient condition? We are going to find the second derivative of the function and put the value of x in that to see whether it is positive or negative. So what we are going to do is, now we're going to find the second derivative. Second derivative of m is d2m by dx square, which is equal to minus w. What does that mean? What does it mean when it is minus w? Can you tell me? Here there is no x. So what does that mean? Minus w. No, it's not anti-clockwise movement, Pratik. Minus w, this is the second differential. So minus w means that it is negative and it is independent of x. It does not depend upon x. That is, it means that the moment at any particular point will always be maximum for that particular point. All right, it can never be minimum. So that is what it means here. So the bending moment is maximum at x is equal to L by 2w. Whatever value of x you get, it will always be maximum at that particular point. So here x is equal to L by 2w. So it is maximum at this particular point. So at x is equal to L by 2w, if I put m uh, is equal to, if I put x is equal to L by 2w in the bending moment function, this is the maximum bending moment that I'm going to get, which is L square by 8w. L square by 8w. All right. So this is the maximum bending moment. I think there's a mistake in the question. I'll just rephrase the question probably. Beam of length L is supported at one end if W is uniformly distributed load per unit length. The question here should be, okay, so this is the question. Just please rewrite the question. I'm sorry about it. There's some mistake. This is the question. Just rewrite this question, please. Hello? Hello? Huh? All right, so have you written this question? Sorry about the problem. Okay, so now we'll go to the next problem. We'll solve the third problem together. This is the third question. Take a minute to write down this question. We need to enclose a rectangular field with a fence. We have 500 feet of fencing material and a building is on one side of the field, so won't need any fencing on that particular side. Determine the dimensions of the field that will enclose the largest area. So that is the question. So basically what is the question thing in the question is that we have a rectangular field on which we're going to place a fence, but we can place a fence only we have only about 500 feet of fencing material, so we can have a maximum, uh, we are trying to enclose maximum area within this 500 feet of fencing material. Now, another thing that is given in the question is that one side there is a building, so that there's no need to fence on that particular side. So this is the question that is given here. So if this is the diagram that I can draw, this is the rectangular area in which we can enclose the maximum area. So the length we'll call it as x, the breadth we'll call it as y. So what we have here is there are two different functions in this problem. All right. The first function is the function that we are trying to optimize, and the second function is called as a constraint. So there is a constraint here, there is a condition here. Constraint means a condition. A condition is also given here. All right. So sketching this situation. So whenever problems of these kind comes, always sketch these diagrams here. That will help you to understand. Now, what are the equations? All right. So in this problem, we want to maximize the area of the field, and that we know that only we can use only 500 feet of fencing material. All right. So the area of the function that the area will be the function that we are trying to maximize, and the amount is the condition, is nothing but your constraint. All right. So the two equations for these are max A, that is we are trying to maximize area, which is equal to x into y. All right. The area of this particular rectangle is given by length into breadth, that is x into y. So that is what we are trying to maximize. So maximize A is equal to x into y. Subject to, there is a constraint given us, that is x plus 2y. This is the side x, this side is y, and this side is y. This side does not require any fencing. So total fencing, that is x plus 2y, is equal to 500. That is the question that they have given, the constraint that they have given. So x plus 2y is equal to 500. So that is the constraint that you are given. If you observe this question properly, there are two variables here. There are two variables at play here. So it becomes difficult. We cannot solve this. We can solve this using the techniques that are taught to us in the sixth unit, but we can convert this into a single variable problem also, and that will be much more easier to solve. So how do we solve this? Okay, now consider the constraint. All right, the constraint is x plus 2y is equal to 500. So x plus 2y is equal to 500. Now I can write this constraint in term of one variable. So let us say that what I am doing is I am going to write this equation as x is equal to 500 minus 2y. All right. So I'm writing this constraint in terms of equation. X is equal to something. So x is equal to 500 minus 2y. And now this value, this equation, x is equal to 500 minus 2y, I'm going to put it in the objective function that we are going to maximize. So here what I'm going to do, put this equation 1 in objective function. Our objective function for area was area is equal to x into y. I'm going to put x is equal to 500 minus 2y here. So area becomes 500 minus 2y into y. If I expand it, it becomes area is equal to 500y minus 2y square. Now we are going to maximize this function. So that is our question now. So we have converted it into a single variable function. All right. So now to find the maximum of this function, we are going to use the classical method again. We are going to use the classical method. The first step is necessary condition, and the second step is sufficient condition. All right. So now what is necessary condition? You're going to find the derivative of that function. Can you tell me the derivative of that function? Derivative of the function? Yes, 500y minus 2y square. If I find the derivative of the function, that will be 500 minus 4y, and I'm going to equate it to 0. Okay, so I'm equating it to 0 to find the value for y. So y, what is the value for y? What is the value for y? 500. is equal to 4y, and therefore y is equal to 125. All right. So we have found out y is equal to 125. So at this point, we know that there is a maxima or minima, and we are just going to make sure that there is a maxima by using the sufficient conditions. So what is sufficient condition? What is sufficient condition? You take the second derivative of the function and find the value. So second derivative, if I find, it is again a constant which is equal to minus 4. So second derivative is minus 4. So at y is equal to 125, the second derivative is negative, which is it is less than 0. So I can say that at this particular point, at y is equal to 125, it is a maximum. So area will be maximum at y is equal to 125. Maxima is at y is equal to 125, and from that I can find out the dimensions of the field. The dimensions of the field will be y is equal to 125, and we know that from our constraint that x plus 2y is equal to 500, and therefore x will be equal to 250. x So x is equal to 250 and y is equal to 125. So therefore, if you look at the constraint, our constraint is satisfied. So 250 plus 2 into 125 is 500. Now, can you tell me the maximum area encompassed? What is the maximum area encompassed in this question? What is the maximum area? So max is equal to xy, that is the function. To find value of max A, all we do is put the values that we have found. X is nothing but 250 and Y is nothing but 125. So multiply it. 250 multiplied by 125. The answer that we get is, yes, come on, tell me the answer. What do you get? What is the maximum area? It is 31,250 units or square units, whatever the units are given in the question. Always write units at the end of the answer to get the exact answer. All right. So that is the area, 31,250 square units. Okay. So with this, we'll stop today. Three questions we solved, three different word problems. These are the kind of problems you can expect in exams. So yes, if you have any questions, you can ask me in the chat box. Does anyone have any queries, questions for these kind of questions? Anyone? Any questions? Okay, so if you don't have any questions, I think we can stop here. Before going in the chat box, give your attendance. You have put roll number followed by your roll number. Yes, I'm going to put this video. I'm going to put this video on YouTube also. By today evening, you should get this video on YouTube. Okay, so I guess everyone has given their attendance. So we'll stop here. I'll put this video on YouTube by today evening. Uh, Tomorrow also we'll conduct an extra session. Tomorrow we'll start with certain region elimination methods. Uh, we'll start with interval halving method tomorrow. All right. Thank you, everyone.